Alright, so I think we're recording. Let's take a look at this problem. We're solving triangles. They'll always give us half of the information that will always include at least one side. Um, we can't solve it if they give us three angles. Um, so in this problem, they give me two of the three angles and a length of A. So uh, I can easily find the measure of angle A because these three angles have to add to 180 by my triangle angle sum theorem in geometry. So I've got 180 minus, if we add this 61 and 83, what do we get for the measure of angle A? Don't forget to put this subtraction in parentheses. You're subtracting the sum. 36. All right. Now I have a known pair. I know the length of A and I know the measure of angle A, so I can use the law of sines. It might be easier for some students to use the law of sines. The equation is a proportion as opposed to the law of cosines. It's slightly more complicated. Um, since there is no obtuse angle, I don't have to worry about finding a particular side in any order. So let's just find the measure, the length of B. So by the law of sines, that the length of B divided by the sine of angle B, this ratio is equal to the ratio of the length of A, which is 62.4, divided by the sine of angle A. We found that to be 36. So this equation is a proportion, and you can solve it by cross multiplying. It's probably easier to just simply multiply along this one diagonal, because then we'll get B. So if we multiply both sides by the sine of 61, we get this. So as long as we can key this in the calculator without making silly type of errors, always take the time to check to make sure that you're in degrees. Let the calculator do the rounding for you, 2 decimals, and when I key in values like times the sine, I don't want to take the sine of 61 divided by, I don't want to take the sine of a fraction, so I have to remember to close that off and then hit the division key and take the sine of 36 degrees. Now the very last parenthesis here it's very forgiving. I'll close it anyway, and then the calculator would have closed it for me. However, the length of B, this is not an angle measure, this is a length, 92.85, and it could be inches or yards or miles or whatever. All right, so we have the three angles, and now we have two of the sides. We know the length of A, we know the length of B. Let's find the length of C. So let's use the law of sines again. I can't do anything like the Pythagorean theorem because I don't have a right triangle. Pythagorean theorem only applies to right triangles. This law of sine and law of cosine applies to any triangle. So let's find the length C by taking the sine of angle C, which was given as 83 here. Let's use the same ratio we did up here, 62.4, which was the length of A divided by the sine of angle A, which is 36. So this length C is 62.4 times the sine of 83 over the sine of 36. So I don't want to make any silly type of errors as I key this in the calculator. Make sure you're in degrees. Make sure you close parentheses. And let's do this. So 62.4 times the sine of 83, and this is what I'm talking about, closing the parenthesis, and then dividing this denominator as the sine of 36 degrees. It doesn't care whether I close that final parenthesis there. So the length of side C is 105.37 units, whatever they are. Alright, so I believe we're done. We found measure of angle A, the length of side B, and the length of side C. It gave us 3 pieces of information. We found the missing 3. Hope that helps, and I'll talk to you later.